Dear students, in the last class we learnt about the Beckmann rearrangement. Beckmann rearrangement means the ketoxine are heated with the acidic reagent. It gives a substituted amides. Okay, this is the mechanism. This is ketoxine. This will be the OH group is attached with the acidic ion, it means H plus ion, and in that the bond will be shifted and H2O is removed. Okay, and then next is H2O molecule is attached to carbocation and it forms a keto group and alcoholic group, and the tautomerism is formed. Tautomerism means shifted of double bond. This double bond goes with nitrogen, this hydrogen bond with oxygen. This is the one method. This is called enol form. This will be changes here. This double bond is goes with oxygen and H is formed with nitrogen. Okay, this is all about the Beckmann rearrangement. Next topic is carbohydrates. Carbohydrates means it is a class of compounds that includes polyhydroxyaldehyde or a polyhydroxyketones. It means the functional group should be polyhydroxyaldehyde or a polyhydroxyketone is present. That is called it as a carbohydrates. In that, carbo means one carbon atom, hydrate means water molecule, two hydrogen atom and one oxygen molecules. Next is importance of carbohydrates. Provides major source of energy, storage form of food in plants and as a starch. Serve as the stored forms of energy as glycogen. Okay, derivative of cellulose such as cellulose nitrate that are used in explosives. Dietary fiber, cellulose acetate is used in photographic film and packing materials. Flavors and sweetness. Okay, next is classification of carbohydrates based on composition. They have a four major types. In that, monosaccharide, it is a simple sugar, or I also call it as a monomer, or a single sugar unit which cannot be hydrolyzed further. Okay, this is the example. Monosaccharides is further classified on the basis of number of carbon atoms. There are 5 types are there, 3 to 7. Okay, trioses, tetroses, pentoses, hexoses and heptoses. Next, second type is, in this class we learnt about other types of carbohydrates. Second type is disaccharides. Disaccharides. Monosaccharides is, it is a single monomeric unit or a single simple sugar or a single sugar molecule is there, but in the disaccharides it is composed of 2 sugar unit. Okay, 2 sugar unit connected by glycosidic linkage. Okay, ಇಲ್ಲಿ ಡೈಸ್ಯಾಕ್ರೈಡ್ಸ್ ಅಂತ ಅಂದರೆ 2 ಶುಗರ್ ಯೂನಿಟ್ ಇರುತ್ತೆ ಅಂತಂದರೆ 2 ಗ್ಲೂಕೋಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇರುತ್ತೆ. ದಟ್ ಗ್ಲೂಕೋಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಈಸ್ combined with the one oxygen atom. Okay, that will be called it as a glycosidic linkage. ಆಯ್ತಾ, ಇದರಲ್ಲಿ this disaccharides further classified into reducing sugar and second one is non-reducing sugar. Okay, this disaccharides further classified. Okay, then example is lactose, maltose, okay, sucrose, etc. Here sucrose gives a which upon hydrolysis it gives a alpha D glucose and beta D fructose. It means 1 molecule of alpha D glucose and 1 molecule of beta D fructose. This is all about the disaccharides. Next is oligosaccharides is present. Third types, it is the oligosaccharides, it is composed of 3 to 10 sugar unit. It means here they have a 3 to 10 sugar unit, so that is called it as a oligosaccharides. For example, rhamnose, okay, raffinose, mainly rhamnose, raffinose, etc. This is the oligosaccharides. Last step is polysaccharides. Okay, polysaccharides. It is this polysaccharide, it is composed of more than 10 sugar unit. More than 10 sugar unit, that is called it as a polysaccharides. Okay, if monosaccharide is a composed of only 1 sugar unit, disaccharide is 2 sugar unit, oligosaccharide is 3 to 10 sugar unit, more than 10 sugar units is present, that is called it as a polysaccharides. It is again further classified into homopolysaccharides, homopolysaccharides means it has same sugar unit, okay. Homo means same. Do you know about that? Homogeneous mixture and heterogeneous mixture. Homogeneous mixtures are completely miscible, okay. So heterogeneous are immiscible, mix up agalladu, aita. Next, second one is heteropolysaccharides. Okay, hetero means opposite of homo. It is constituent sugar which are different sugar unit. Okay, the example for homopolysaccharide is starch, glycogen. Homopolysaccharides examples is starch and glycogen. Examples for heteropolysaccharides is agar or agarose. Okay, you have to know the examples mainly. Then we move on to the reducing and a non-reducing sugar. That is very important. Okay, you have to know about the reducing and non-reducing sugar. First we have to know about the reducing sugar. This is the disaccharide type. Okay, carbohydrates which taste sweet are generally referred as sugars, and those which does not taste sweet are called as non-sugars. Do you get it? ಯಾವುದು ಸಕ್ಕರೆ ಅಂಶ ಇರುತ್ತೆ, ಈಗ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ನ ನಾವು ಟೇಸ್ಟ್ ಮಾಡಿದ ತಕ್ಷಣ ಸಕ್ಕರೆ ಅಂಶ ಇರುತ್ತೆ ಅಂತ ಅಂದರೆ ದಟ್ ಈಸ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಶುಗರ್. ಸಕ್ಕರೆ ಅಂಶ ಇಲ್ಲದೇ ಇರುವಂಥದ್ದನ್ನು ನಾನ್ ಶುಗರ್ ಅಂತ ಕರಿತೀವಿ. ಗೊತ್ತಿದೆ ಅಲ್ವಾ? ಇದರಲ್ಲಿ ಫಸ್ಟ್ ಒನ್ ಈಸ್ ರೆಡ್ಯೂಸಿಂಗ್ ಶುಗರ್. Reducing sugar ಅಂತಂದರೆ first we have to know about the definition. Here reducing sugars are carbohydrates. We know that carbohydrates possesses free aldehydic or ketonic functional group. Okay, ketonic functional group, and that groups reduces the Fellings and Tollens reagent. ಗೊತ್ತಾಯ್ತಾ? ಫೆಲ್ಲಿಂಗ್ಸ್ ಟೆಸ್ಟ್ ಮತ್ತು ಟಾಲನ್ಸ್ ರಿಯೇಜೆಂಟ್ ಟೆಸ್ಟ್ ಅಂತ ಬರುತ್ತೆ. ಫೆಲ್ಲಿಂಗ್ಸ್ ಟೆಸ್ಟ್ ಅಂತ ಅಂದರೆ ಫೆಲ್ಲಿಂಗ್ A and ಫೆಲ್ಲಿಂಗ್ B solution is present. That solution should be converted to red color. Okay, that is the carbohydrate is reducing sugar. And also tolerance reagent means that is ammonical nitrate solution, and that solution is converted to silver mirror. Black precipitate of silver mirror is present, so that will be called it as, if it is that precipitate is formed, the sugar is called it as a reducing sugar. Okay, this carbohydrates which one have a aldehydic and ketonic group, functional group, that can reduce the Fellings and Tollens reagent is called a reducing sugar. ಈ ಥರ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಇದ್ದು ಅದು ಟಾಲನ್ಸ್ ರಿಯೇಜೆಂಟ್ ಮತ್ತು ಫೆಲ್ಲಿಂಗ್ ಸೊಲ್ಯೂಷನ್ಸ್ನ ರೆಡ್ಯೂಸ್ ಮಾಡಿದೆ, ದಟ್ ಈಸ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ರೆಡ್ಯೂಸಿಂಗ್ ಶುಗರ್. ಯೂಶಲಿ ಆಲ್ monosaccharides are reducing in nature. Okay, reducing in nature. For example, glucose, mannose, galactose, etc. Okay, here disaccharides with the anomeric hydroxyl group free are also reducing in nature. Anomeric hydroxyl groups are present in the disaccharides. That should be also call it as a reducing sugar. For example is maltose and lactose. If it is anomeric group is present, anomeric hydroxyl group, only OH group is present. Do you get it? The carbon atom should contains only OH group. Then that is present in disaccharides or also in reducing agent. The example for that is maltose and lactose. This is all about the reducing sugar. Next, second one is non-reducing sugar. Non-reducing sugar is opposite of reducing sugar. Non-reducing sugar is opposite of reducing sugar. Reducing sugar anta andre it have a aldehydic group and a ketonic group. But here the carbohydrates which do not possesses free aldehydic or ketonic group. Okay, ketonic functional group. Here this non-reducing sugar does not reduce the Fellings and Tollens reagent, that are called it as a non-reducing sugar. For example, sucrose, mainly sucrose, and also the polysaccharides are non-reducing in nature. The polysaccharides are in the reducing sugar, the monosaccharides are reducing in nature, but in the non-reducing sugar the polysaccharides are non-reducing in nature. Non-reducing in nature, for example, cellulose, starch, glycogen, etc. Starch, glycogen, etc. This is all about the reducing and the non-reducing sugar. Okay, in that we have to know about the definition and examples. Okay, next is monosaccharide is there. monosaccharide. The main example for monosaccharide is glucose. You know that example is glucose. ನೆಕ್ಸ್ಟ್ ಇರುವಂಥದ್ದು ರಿಯಾಕ್ಷನ್ಸು ಮತ್ತು ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಗ್ಲೂಕೋಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳುವಂಥದ್ದು. ಓಕೆ, ಗ್ಲೂಕೋಸ್, ಯು ನೋ ದಟ್ ಗ್ಲೂಕೋಸ್ ಇಟ್ ಈಸ್ ಮೋಸ್ಟ್ ಕಾಮನ್ monosaccharide present in all the plants and animals. It should be present in all the plants and animals, and also fruits. Fruits also contain sugars. So grape contains mainly glucose. Okay, ಇದರಲ್ಲಿ ಈಗ ನಮಗೆಲ್ರಿಗೂ ಗೊತ್ತಿರೋ ಪ್ರಕಾರ ಪ್ಲ್ಯಾಂಟ್ ಮತ್ತು ಅನಿಮಲ್ಸಲ್ಲಿ ಗ್ಲೂಕೋಸ್ ಇದ್ದೇ ಇರುತ್ತೆ. ಫ್ರೂಟ್ಸಲ್ಲಿ ಗ್ಲೂಕೋಸು ಕೂಡ ಇರುತ್ತೆ. ಅದರಲ್ಲಿ ಮೇಯ್ನಾಗಿ ಗ್ರೇಪ್ಸ್ ಕಂಟೈನ್ಸ್ mainly glucose, and hence it is also called as a grape sugar. Okay, and this glucose is dextrorotatory. Okay, so it is called as dextrose. So is called as dextrose. Why it is called as dextrose? Because the glucose is dextrorotatory. Okay, then usually human blood contains normal range of glucose contains 65 to 135 milligram per 100 ml. ಅಂತಂದರೆ 100 ml ಬ್ಲಡ್ಡಲ್ಲಿ ಇಷ್ಟು ಗ್ಲೂಕೋಸ್ ಇರಬೇಕು ಅಂತ. ಓಕೆ, ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಒಬ್ಟೈನ್ಡ್ ಬೈ ದ ಹೈಡ್ರಾಲಿಸಿಸ್ ಆಫ್ ಸ್ಟಾರ್ಚ್ ಆರ್ ಬೈ ದ ಹೈಡ್ರಾಲಿಸಿಸ್ ಆಫ್ ಸುಕ್ರೋಸ್. ಓಕೆ, ದಿಸ್ ಗ್ಲೂಕೋಸ್ ಈಸ್ ಒಬ್ಟೈನ್ಡ್ ಬೈ ದ ಹೈಡ್ರಾಲಿಸಿಸ್ ಆಫ್ ಸ್ಟಾರ್ಚ್ or by the hydrolysis of sucrose. This is all about mainly about glucose, where it is present. Okay, it is most common monosaccharide. It is present in all the plants and animals, and also in the fruits. Grapes mainly contains glucose, so that's why it is called as a grape sugar. Human blood and in the human blood it has a 65 to 135 milligram of blood per 100 ml of 65 to 135 milligram of glucose per 100 ml of blood. Okay, next this is the very important reactions of glucose. It means ಯಾವುದ್ಯಾವ್ದ್ರ ಜೊತೆ ಗ್ಲೂಕೋಸು ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ಅಂತ. ಓಕೆ, ಇನ್ ದಟ್ ಫಸ್ಟ್ ಒನ್ ಈಸ್ ವಿತ್ hydroxyl amine. With hydroxyl amine, the molecular formula of hydroxyl amine is NH2OH. Okay, first you have to write a glucose. How many number of carbon atom are present? 6. 2, 3, 4, 5, 6. Okay, this is aldehydic form of ketone, aldehydic form of glucose. OH, H, H, OH, 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 H, H. This is CH2OH. This is the structure of, or molecular, not a molecular formula, structure of D-glucose. Okay, here NH2OH, hydroxyl amine, in that NOH H2. Here I am splitting this one. Okay, this oxygen and hydrogen should be removed. Okay, and then it forms C double bond NOH. Instead of oxygen, NOH is substituted, and this is H, and this is COH, H, CH, OH. Okay, next COH, H, COH, H, CH2OH. This is D-glucose oxime. You know that in the anti and syn geometrical isomerism, anti and syn isomers, there will be oximes is formed, aldoximes and ketoxime. Here this is the oxime, glucose oxime. Okay, the C double bond N OH is formed. This is all about the reaction with hydroxyl amine. Here water molecule is removed, oxygen atom from the glucose and hydrogen atom from the hydroxyl amine, so it gives a oxime. Okay, next second one is reaction with hydrogen cyanide. Second one is reaction with hydrogen cyanide, HCN. Okay, ಇದಕ್ಕೇನೆ ನಾನು ಡೈರೆಕ್ಟಾಗಿ ಬರಿತಾ ಇದ್ದೀನಿ. You have to see here for HCN. ಇಲ್ಲೇ ಗ್ಲೂಕೋಸ್ ಮಾಲಿಕ್ಯೂಲ್ ಇದೆ, ನಾನು ಮತ್ತೆ ಬರಿತಿಲ್ಲ. ಓಕೆ, you have to see here HCN. It is reaction with hydroxylamine. This is reaction with HCN. Then the reaction is CHOHCN. Okay, in this H will be bond with CH and this H bond with OH and CN is substituted. Do you get it? ಇಲ್ಲಿ ನೋಡಿ HCN ಇದೆ, ಒಂದು H ಕಾರ್ಬನ್ ಜೊತೆ ಬಾಂಡ್ ಆದರೆ ಇನ್ನೊಂದು H ಆಕ್ಸಿಜನ್ ಜೊತೆ ಬಾಂಡ್ ಆಗುತ್ತೆ. ಆಯಿತಾ, CN ಈ ಕಡೆಗೆ ಬಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗುತ್ತೆ. ದೆನ್ COH H CH OH COH H COH H CH2OH. This is D-glucose cyanohydrin. This is D-glucose cyanohydrin. Okay, this is all about the reaction with hydrogen cyanide. ಇಲ್ಲಿ ಗ್ಲೂಕೋಸ್ ಮಾಲಿಕ್ಯೂಲ್ನ ಬರ್ದಿಲ್ಲ. ಆಯಿತಾ, ಇದಕ್ಕೇ ಡೈರೆಕ್ಟಾಗಿ ಕನೆಕ್ಷನ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಇಲ್ಲಿ ಈ ಕಾರ್ಬನ್ ಜೊತೆಗೆ ಇಲ್ಲಿರುವಂಥ H ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಬಾಂಡ್ ಆಗುತ್ತೆ, OH ಆಗುತ್ತೆ, CN ಆಗುತ್ತೆ, ಇನ್ನು ಮಿಕ್ಕಿದ್ದೆಲ್ಲ ಸೇಮ್ ಇರುತ್ತೆ. ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಜೊತೆ ಮಾತ್ರ ಚೇಂಜ್ ಆಗುವಂಥದ್ದು. ಯಾಕೆ ಅಂತಂದರೆ ಎಲ್ಲಿ ನಿಮಗೆ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಇರುತ್ತೋ, ವೇರ್ ಇಟ್ ಈಸ್ ದ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಈಸ್ ಅಟ್ಯಾಚ್ಡ್, ದಟ್ ವೇ ದ reaction will be taking place and other will be same. This is the D-glucose because OH group is present on the right side. Okay, dextrorotatory, always it is a dextrorotatory, so it is called as a dextrose. This is all about the reaction with hydroxylamine and reaction with hydrogen cyanide. Next they have a other reactions. I will explain you in the next class.